So sometimes if it doesn't meet the rule of squares, then we can use what's called an approximation. And the approximation basically means that the approximate value of x is going to be less than 5% of the initial concentration. All right, and like you, basically if the initial is 1,000 times greater than k, you can use approximation. Okay, so I'm going to show you what that means. So in this case, I have 10 to the minus 7. Okay, so 1.67 times 10 to the minus 7. And I have 0.0125 and concentration per 0.5. So really, remember, it's how important it is that you do this when it's telling you moles. So the molarity of this is 0.0250. 0.0250. So when I look at that, 10 to the minus 7, okay, is what we call very small. And you might see me say that. The Kc is very small in relation to the concentrations. So since it's very small, that is, it's 1,000 times smaller than what we're doing, we can use what's called the rule of approximations. So my initial, and I'm doing this for you. You got to remember to do this though, to always look and see what your volumes are, because if you just read through this and said 0.0125, you would be off. You'd be half as much as you were supposed to be. So 0.0250. All right, and so we have 0. We have 0 for these, so they are the product. So that means that I'm going to go down with my H2S, and it's got 2 moles, so it's minus 2x, and my H2 is plus 2x, and my S2 is plus x. So my equilibrium concentration for this one is going to be 0.0250 minus 2x, and x. All right, and that don't look like a square, so oh no. All right, so Kc, which is equal, very small, 1.67 times 10 to the minus 7. Like I said, in most problems, if it's 10 to the minus 5 or smaller number than that, you're going to be pretty much good to go with approximation, okay? All right, and remember, I told you I'm not going to give you one that is a quadratic. So if you, on the test, you do have to do them in homework, okay? Because I got to know that you can do it. But in the interest of you having enough time to finish your test, you're just going to be doing these others. 1.67 times 10 minus 7 is going to be equal to 2x squared times x divided by, there's a lot of x's on this, 0.0250 what? Minus 2x. Stop doing that. Okay, that's ugly. Oh, and that's squared. But that's not a perfect square, right? It's not. So, but it is very small. And so what that allows me to do is when I am calculating this, if I have something that's subtracting the x, I can approximate that is basically 0, because it's not really going to change that number. Because 2 times 1.67 times 10 to the minus 7 is 3 times 10 to the minus 7. So 0.0250, let me show you. 0.0250 minus 2 times 1.67 times 10 to the minus 7 is still going to be 0.0250. So that's why I can use approximation for that. And I don't have to go through all that extra math, because it doesn't make any difference anyway. Now, if you're anal about this, and I guess that's an okay word to say, and you really want to do that, then you can work all of them with quadratics. So if you are a math genius and you like it, then, and you can do it, quick enough to get through the test, you can do a quadratic on all of these. But I'm just telling you how to avoid it. If you're like me, you want to do it the easiest way, right? So I'm going to use the approximation on this, which means when I do this calculation, I'm really going to do it as 2x squared times x divided by 0.0250. So I'm leaving this minus squared. So I'm leaving that minus 2x off of there. Okay, so, and then that's also equal to, and make sure you do this right because this whole thing is squared. So that's like 4x squared times x, which is 4x cubed, divided by 6.25 times 10 to the minus 4. That's 0.0250 squared. All right, so 1.67 times 10 to the minus 7, which is KC, I forgot all about it because I was doing all that other stuff, is equal to 4x cubed divided by 6.25 times 10 to the minus 4. So I got to multiply that over there. So 1.67 times 10 to the minus 7 times 6.25 times 10 to the minus 4 is equal to 4x cubed. Now remember when I was doing perfect squares, I had to take the square root of both sides. Now, since I have a cube, I'm going to have to take the cube root of both sides. So cube root and cube root, right? Now, I probably need to get, before I do that, because that's what I'd do, I'd be going, oh yeah, take the cube root. You got to get rid of this 4 first. Okay, so I'm going to erase this, and you probably haven't written it down yet. So anyway, so I'm just going to go back through this. So the 1.67 times 10 to the minus 7, which equals the 4x times 6.25 times 10 to the minus 4 is equal to 4x cubed. All right, so before I get all crazy and start doing things, I've got to get rid of that 4. So I divide both sides by 4. So 1.67 times 10 to the minus 7 times 6.25 times 10 to the minus 4 times, no, divided by 4 equals x cubed. Now that I've just got x cubed, and I can take the cube root of that to make that x, and that'll give me x if I take the cube root of the number side. So I'm going to take the cube root of this and the cube root of that, and so that's going to give me x over here, and it's going to give me 2.97 times 10 to the minus 4, which is the cube root of this whole thing right here. Okay? And again, your calculator can be your friend or it can be your worst enemy, so make sure you know how to use it. All right, so the concentration of H2 is equal to 2x. So 2 times 2.97 times 10 to the minus 4 is going to be 5.93 times 10 to the minus 4 molar. The concentration of S2 is equal to x, so that's going to be equal to 2.97 times 10 to the minus 4. And then the H2S, when we get done, is equal to, now you got to use that x when you go back, so 0.0250 minus 2x equals 0.0250 minus 2 times 2.97 times 10 to the minus 4. That's going to give you 0.0240. Now, it did change a little bit, didn't it? But it is close enough, okay, that that approximation is okay. All right? So if I tell you that it's very small, or if you see it's negative 19 or something like that, it's totally okay to use approximation. All right? So those are your concentrations. Oop. Okay? Isn't this fun? I promise the next section will actually be fun. All right? And so you have plenty to practice in this part. That's why I'm keeping them short and sweet. So go back and work these problems. Make sure you can get them done.